Hello and welcome to this video on the open-closed principle, one of the 5 solid principles of object-oriented programming. In this video, we're going to define what the open-closed principle is and why it's important for writing clean, maintainable code. We'll also explore 2 examples of code that violate the principle, and show you how to refactor them using polymorphism and abstraction. First, let's define what we mean by the open-closed principle. The principle states that a software entity, such as a class or module, should be open for extension but closed for modification. In other words, you should be able to extend the behavior of a software entity without changing its source code. Why is this important? Well, imagine you have a large software project with many different classes and modules. If you need to change the behavior of one of those classes or modules, you may end up inadvertently introducing bugs or breaking other parts of the system. By following the open-closed principle, you can reduce the risk of these types of problems. To understand the OCP better, let's consider an example. Suppose you're building a simple e-commerce application that allows customers to place orders. Initially, the application only supports payments using credit cards. However, you know that in the future, you may want to add support for other payment methods, such as PayPal or Apple Pay. Certainly. Here's an example of code that violates the open-closed principle. In this example, the order class has a process payment method that checks the value of the payment method property and performs different actions depending on its value. This code violates the open-closed principle because it's not open for extension. If we want to add support for a new payment method, we'll have to modify the process payment method and add another if statement, which is not a good practice. To apply the OCP to this scenario, you should design your code in such a way that it can handle new payment methods without having to modify its existing code. One way to do this is by using polymorphism and virtual methods. In this example, we have an abstract class called payment method that defines a virtual method called process payment. We then have 2 concrete classes that derive from payment method and implement the process payment method for credit card and PayPal payments. Finally, we have a payment processor class that takes a payment method object and calls its process payment method to process the payment. By using polymorphism and virtual methods, we can easily add support for new payment methods in the future without having to modify any existing code. Another way to apply the OCP is by using abstractions. Let's consider another example. Suppose you're building a drawing application that allows users to draw different shapes, such as circles and squares. Initially, the application only supports drawing circles and squares. However, you know that in the future, you may want to add support for other shapes, such as triangles or rectangles. In this example, the drawing application class has a list of object types, which means it can store any type of object. The addShape method takes an object as a parameter and adds it to the list. The drawShapes method then loops through the list and checks the type of each object using if statements. This code violates the open-closed principle because it's not open for extension. If we want to add support for a new shape, we'll have to modify the drawShapes method and add another if statement, which is not a good practice. To apply the OCP to this scenario, you should design your code in such a way that it can handle new shapes without having to modify its existing code. One way to do this is by using an abstraction, such as an interface or abstract class. In this example, we have an interface called iShape that defines a draw method. We then have 2 concrete classes that implement the iShape interface for circles and squares. Finally, we have a drawing application class that has a list of iShape objects and methods to add shapes. In conclusion, the open-closed principle is an important principle to follow when writing object-oriented code. By designing software entities to be open for extension but closed for modification, we can make our code more flexible, easier to maintain, and less error-prone. When we violate the open-closed principle, we end up with code that is brittle and difficult to change. However, by using techniques like polymorphism and abstraction, we can refactor our code to follow the open-closed principle and make it more adaptable to future changes. So, keep the open-closed principle in mind when you're writing code, and you'll be on your way to creating more robust and maintainable software. Thanks for watching.